Now, we cannot blindly use hash table, so we need different ways of. Welcome back. Today we're solving another very interesting problem. With the recent boom with social networking sites, one of the key questions that are often asked in interviews is how to implement such a site, how to implement pairing, or how to match people using their attributes. So if you look at the dating sites or any kind of social networking sites, they match users based on their common interests, their attributes, their choices. Now, how do you implement such things? So there are ways of doing this. We'll focus on a technique that uses hash table to solve the matching problem. So our problem is of matching attributes. Now, we cannot blindly use hash table, so we need different ways of using hash table. Now, case 1, which is the easier case, is the attributes are well defined. So if the attributes are very well defined and they are small in number, and also the attributes can have a yes/no value, for example, or the number of values per attribute is limited. Number of values per attribute is limited. In this case, we can have an integer representation of each attribute, and based on number of values it can take. For example, there is one attribute, say a, I, and number of possible values that the attribute can have, say 4. So we can use a 2-bit vector to represent all the 4 possible values of the attribute. And then we have a set of attributes. So we can take that set of attributes and then create an integer for each attribute. So maybe it has a1 through an, and for each you'll need a bit vector. And then you'll come up with a bit vector which is a packing of the individual bit vectors. And then you design your hash function that will take this packed representation of attributes in a bit vector and map it to a hash key. And that gives you the hashing table. So your hash table will look like a mapping of the packed bit vector into a key field, and your data will be the attribute list. Okay, and now you have multiple users in the site. So for each of them you have a set of attributes, and then you apply the hash function, and the sets of users that maps to the same key, they end up being paired together. So that's one way. However, this technique may not be as useful if the number of attributes grows very large. So if you have thousands of attributes, for example, you won't be able to pack them in a single integer. Or even if you have a smaller number of attributes, but each attribute can take many values, because the attributes may not be discrete, they may be continuous, and it will be hard to discretize the attributes and pack them into integers. So an attribute can have many different ways. So for example, somebody's skills can be rated not in a 1 to 4 scale, but it could be 1 to 20 scale, or there could be all sorts of attributes which cannot be just packed in like 4 different values. So in those cases this becomes infeasible, because then you won't be able to have a bit packed representation of the attribute list, and you won't be able to use the hash function. In those cases, what you should do is a very interesting technique that known as the min hash technique. So in this case, you, instead of creating a single hash function, you create a list of hash functions, and each hash function works on a given attribute. So you have, for attribute AI, you come up with a hash function, for each of AIs you come up with hash functions. And so for each set you have A1 through AN attributes, and then you defined a capital mean K of the attribute list S is equal to minimum of all attributes belonging to AI belonging to the set, and HK is the hash function that you are applying on that individual attribute. So for each choice of K you will end up with a list of hash functions or hash values. So for each set S or each user which has multiple attributes, you came up with a list of hash functions, say M1S, M2S up to MKX, and the choice of K is up to the algorithm. So based on how similar you want the users to be, because sometimes you want to group the users not based on exact match, but you want to group them based on similarities. Like some people have similar choices, they may not be exactly same choices but similar choices. So this choice of K, like how many hash functions you want, is really based on that, like how similar you want the users to be. So if you have a very large K, that means you want the users to be very similar. You want the user to be exactly similar, for example. Or if you have a smaller K, that means you are okay with users being somewhat similar. So you came up with K different hash functions for a given set of attributes for a given user. And then by applying those hash functions, you created a list of hash functions. So this K may not be equal to N. So N is the number of attributes, because you don't want them to be exactly same. Even if they're similar, it's fine. So you basically come up with a sequence of hash values for each user. And then it becomes another hashing problem where you want to pair users based on how close the sequence look like. So for user S1, you will end up with M1 S1 through MK S1. For user S2, you will end up with the sequence of hash, say M1 S2 through MK S2. And then you have another high level hash function which takes the sequence of hashings and then maps them. And so users having similar sequence will map to the same key. So that's called a mid-hash technique, and that's also fairly commonly used by the social networking sites. Hope you enjoyed our solutions. We'll get back to you with more such interesting interview problems in our next presentation.